Hello, everybody. Zach's first show, Antrea Live. It's January the 19th, 2022. So, Zach, take it away. Everybody, y'all know me and a meme. Let's do some introductions before you start, if that's cool. Vlad, you want to introduce yourself?
Okay, cool. Hi, guys. My name is Zach. I'm excited to be here in so many ways. For a brief self-introduction, previously I have worked as an engineer on platform infra field for a few years, range from deploy, CI/CD automation, monitoring stuffs. I'm currently working in the Tanzu InfoX team, working on the Kubernetes networking stuffs. Yeah. And also, I think maybe other people can do self-introduction, like Fang.
Maybe I can go next. Yeah. Hi guys. My name is Fang Han. I'm a software engineer also at infra team focusing on downstream networking. I just joined the company by 6 months.
Yeah, and also very welcome, Vlad, coming here. Previously, when we are doing this project, doing the service validator, Kubernetes service validator, we got a lot of help from Vlad to run this validator on using sonobuoy. So by that, we can just run this project in any Kubernetes cluster very easy.
Awesome.
Thanks for that. Okay. Oh, sure. Yeah,
so I guess I should introduce myself then, since you mentioned me. My name is Vladimir Vivian. I'm engineer at VMware, working on open source stuff. Sonobuoy, I think is going to be discussed today, which is one of the projects I've worked on. So cool. Definitely just happy to be here and add whatever I can add to the discussion.
Cool, great, awesome,
cool,
nice. Maybe I can share my screen so we can start.
Yeah. Yep, I think I see it. I think you're sharing your other one.
Oh.
Hey, what's up, Arun? I see people are starting to roll in. Looks like Lubron is here. Hey, Lubron. Junjen is here. All our friends. Junjen over from the Antrea team, and Per is here. And I know Per had an interesting question. We'll get to your question in a little bit, and Junjen can help answer it, Per, about the OVS NSX stuff. Okay, cool. All right. Yep, we see you, Zach. I'll turn your screen on.
Cool. Thank you.
Cool.
Okay, first of all, we have a new release. Can you see my screen? Okay, cool, nice. So first of all, we have a new release of Antrea, which is 1.5, which is great. I hope there are some people from Antrea team. I think if you can add what's outstanding feature inside of 1.5 versus 1.4 would be great. Yeah. And to the second one, let me open it.
Yeah, so 1.5, Junjen. What's the if you want to leave some release notes for us in the stream about any new features that are interesting, worth talking about, let us know. And now what do you got here, Zach? What's this?
Okay, this is one Kubernetes IDE which I use to visualize components inside of any Kubernetes cluster, which is very useful. I'm not sure if people are using it, but I want to share this. So if you open Lens, it can, if you have the kube-config file on your local, you can just visualize anything inside of the cluster. So in this cluster, we have some pods and services. We don't have any deployments. Okay, so maybe this is a bad example of the cluster.
Looks like a couple other people joined. So Zach, we only see Lens here, but
Oh,
it looks like Eleanor joined. Eleanor, do you want to do a quick introduction?
Absolutely. This is my first time using this platform. Can you hear me?
Yeah.
Yes. we can
Great.
hear you.
Excellent. Thanks for having me. I'm Eleanor Millman. I'm a VMware product manager, and I'm here today because I am the new-ish sonobuoy PM. So we're product managers. So we've been devising what we think is a pretty exciting sonobuoy strategy, and maybe we'll get to discuss that a bit later.
Is John
cool.
joining us?
I believe he's backstage, so if someone wants to let him on,
Oh,
he
okay.
is.
Cool.
Oh, do we have a limit? I think we have a. Oh, there you go. All right.
We got John's here. I was just waiting to see his camera because we're on live TV, and I just want to make sure everybody's got their cameras on before. No, your mic is off, John.
Hey there. Hey
There you go. Now we hear
Turned on
you.
the camera to get the invite, but I didn't want anyone to hear me, I guess.
Yeah.
Well, thanks for having us.
You want to give us a 5-second intro? We're rolling, but
Sure,
I wanna
yeah.
know who you are.
So I'm John Schnocky. I work with Eleanor on the sonobuoy team, and happy to. I'm really excited to see what y'all built as a sonobuoy plugin, and curious to see how we can help and kind of advertise how other people can use sonobuoy to help themselves test things.
Cool. And if you all saw that Junjin left some notes about 1.5 multicast IPAM enhancements, multi-cluster service API support, SRIOV stuff. So we can talk more about that later. But yeah, go ahead, Zach. Keep going.
yeah, okay. Thanks for joining. Yeah, so using Lens, you can very easily to see what's inside of the cluster, how many pods, what's the config map, deployments going on, stateful set, replica set, these kind of things. Yeah, so current cluster is very empty actually. So this is just for testing. So I have four pods, 4 nodes running, and there are some pods in there. Yeah, try it. It's very useful and very easy to use.
How's that compared to Octant?
This one is IDE, so you need to install it on your local machine. So it's not open in the browser.
Oh, I see.
And also you can add more clusters here if you have more different kube-config files.
Mm-hmm.
So easy to switch different ones. Okay, cool. We can go to the next one. Yeah.
Back in your browser again? Should I turn the browser back on? Okay, cool.
Yeah, cool. Yeah, there's an article about 5 Kubernetes trends to watch in 2022. Yeah, so Kubernetes as a platform for everything. I do want to call out the second one actually. So Kubernetes and machine learning. So we can run. So Kubernetes is very suitable for to run machine learning workloads on the prime or hybrid or public clouds. There is there is a very very popular tool, which is Bento ML, which is very interesting. I just found. Actually, it's created by my friend. It's got 1,000 of stars. You can if you want to run machine learning workloads on Kubernetes easily, you can try this out.
There's Bento, there's Kubeflow. What else is there? And then Spark has a native implementation. Didn't Spark have MLlib? I don't know if people use that as an alternative.
I'm not very specialized in machine learning workloads, so yeah. I just know the features about it to run the workloads very easily on Kubernetes. So you don't need to set up the clusters by yourself. It can do the automations for you. Yeah.
Cool.
Yeah, maybe people with machine learning knowledge can
Yeah.
know,
So is this?
can help.
Do you know, is Bento ML more for like the actual workloads themselves, or is it to help you set up a cluster capable of running machine learning apps just more effectively, right? To make sure you have the right hardware in place and that sort of stuff, you know?
Yeah, I think this is a good question. We can check it out together later. I think should be for both, so it can easily to automate you to start up the cluster and then run the binaries of machine learning into the clusters.
Cool.
Okay, let's go to the next one. There's a question for Antrea.
Yeah, so Per is here on the show, and Per, Junjin, if you're around, so he was asking us NSX and Antrea and OVS. So how do those three technologies work together? So like when you get NSX native integration with an Antrea CNI, like what's the interface there? Like, is NSX using OVS under the hood to help with Antrea related stuff and to monitor traffic and to do all the stuff that we put on top of it? Or you could kind of answer us, like he could actually answer us asynchronously, Zach, and then you could move on to the demo so that we get going with stuff, because there's a lot of people here, so I'm sure people are ready for the main course now.
Okay, cool. Yeah, let's get into the project. So the project name is Kubernetes Service Validator. It's open source. Jay and Amit did the first commit. This is very useful tool to test the networking functionalities, to test the pod-to-pod connectivity. The reason why we created this tool is as Kubernetes gets more and more popular, and it gets applied to different cloud providers, on-prem, hybrid, multi-cloud, on different networking devices like switches. And lots of core networking module evolve, and the service proxy is evolving quickly. So currently we have many different CNIs like Calico, Antrea, Cilium, and nodes running on different OS like Linux and Windows. And also we have different DNS like Core DNS and kube-DNS, different service mesh, Linkerd, Istio, and even kube-proxy has two modes, IPVS and IP table. I think it's three. So, but mainly IPVS and IP table, which makes it very hard to target and identify networking failures. So sometimes when you run the networking E2E test, it's very hard to target the exact networking problem of the cluster. So you don't know. So when there is a networking issue, you don't know it's because of pods inside of the same node has a connection issue, or pods from different nodes has a connection issue. So that being said, we are developing this very easy and powerful tool to validate the networking connectivity between pod to pod, container to container, and produce a very intuitive visibility of networking connections inside of clusters. So we are trying to make it visible.
Yeah, and I'm just going to interject there that, like, we found that there's not a lot of exercising of the service proxy when you run K8's conformance tests. There's a little bit. There's a few tests, like 5 or 6 out of 300 that use it. Like I think there's one of them is a session affinity test. One of them does node port conversion to external name. There's a few, but like there's like hundreds of other tests, and there's several SIG network tests that test various behaviors inside the kube-proxy, but they're kind of tricky to debug when there's actually something wrong, because they create a pod and they delete a pod, and you kind of just have to like wait and see. And a lot of times what you have is that your proxy might be down on one node but not on another, and things work in one place and not on the other, and so on and so forth. You might have slowness with etcd or your API server. And so we always see this with customers where they have their network down and they think it's DNS, or they think it's services, or they think it's that node ports aren't working correctly or whatever, but actually it might have something to do with pod readiness, or it might have to do something with the particular node that they're probing things from. Like one particular node might be down. And so it's like you get into this game of whack-a-mole where you're trying to test 3 things at the same time: the network, the topology of the cluster, and a bunch of other stuff.
And is almost the only error message you get when debugging all these network issues like timeout?
Yeah, that's all you ever see, right? Is a timeout. So,
okay.
So that's like Amin did the initial prototype of this, demoed at SIG Network about a year ago, and then Zach has actually made it like production ready and powered it by sonobuoy now. So, Zach, can you zoom in a little bit so we could see what's going on your screen there a little bit better?
Yes, sure.
Cool. Yeah, beautiful. All right.
Okay.
Fang Han has also been working really hard with Zach on this recently too. So, yeah.
Yes. Yeah. Thanks for that, Jay. Okay. For the design part of this project, we want to ensure it will be run it will be very easy to run, and also ensure to cover as many networking solutions as possible, different CNIs, different proxies, and to ensure to deliver the networking validation in a very intuitive and visible format. We can think about this project as a sphere which can pierce into any Kubernetes cluster and identify the networking obstacles. So, So for the visualization, I think we can jump into this metric first. So we can see each pod if they can connect to other pod. So in the metrics, if it's okay or if it's fail, then it implies the connectivity. So currently we are in the project CI. We support different CNIs and proxies combination, networking solutions combination. So we support Antrea proxy and Calico with eBPF, and also kube-proxy in IP table modes, kube-proxy in IPVS mode, and also CDM.
Yeah, and I think by support, it's like more, like you said, like CI. So we're kind of testing all these different added-on proxies to see whether they behave the same, whether they have the same semantics with respect to mutations that happen in services and so on and so forth. So yeah,
and we have developed a very convenient tool to aggregate the reports from different CIs. We can see if the testing pass on different networking solutions. So in CDM, we can pass different tests, which test failed, and also on Antrea and also on kube-proxy, which test passed and which test failed.
So as you could all expect, the kube-proxy IP tables works perfectly.
Yeah, that's interesting and tricky actually. Later I will show you what's the behavior difference between IP table and IPVS in Kubernetes in kube-proxy. IP table has some behavior difference than expected in session affinity functionality actually.
Yeah, Zach Zach actually has found some different behavior using these diagnosis tools, and they behave differently, and we can use this tool to visualize those kind of unexpected behavior.
Yeah, we can cover it later after showing the project to the audience. So when we are trying to testing the existing cluster, when we want to use this project, actually we will not touch the existing pods and service in the cluster. We will when we run the project, we will inject the testing pod into all the nodes in the cluster and create the services we want to test in the cluster, like cluster IP, node port, external name, even node port local, these services. Yep. So this is how do we do the test. And then after the pods,
so the pod stays stationary. We spin up all the pods, and then we move the services in and move them out, right? And the nice thing about that is it's fast, right? Because you can boom, 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 pull over and over again. And you're not sitting there and exercising etcd and all these other things that you don't care about, right? You're not testing how long, you don't have this weird 2-minute latency between tests. So all these run at about 5 minutes at this point, right, Zach? Like we've got, what do we have, like 12 different tests, and they all finish in about 4 or 5 minutes?
Yeah, actually, totally just 8 minutes. 5 to 10 minutes. Around 8, actually, totally. Yeah, not.
And that's why this is a separate repo, because if we were to do this using the regular Kubernetes E2E test harnesses, there's kind of a rule in there that the tests are stateless, and so you can't like carry over in a scaffold from one test to another, which is why we did this in its own repo.
Yeah, exactly. And also, after the test is done, we generate the report, and then we decommission. And then we decommission the service and pods. Out of the cluster. So
I like your little Miro animation that you're doing there. That's a good trick, Zach.
It's manual automation.
Little live animation. Okay, cool.
Yeah. Okay, cool. So inside of the project, when the pods and service are set up, how do we do the test? We set in each of the tests, we set the cluster IP service or node port service to the pod, and we enable a pod to connect with each other using agent using the connect using the connect command to reach out to each other and see if the connectivity is successful or not. And then we generate the metrics. Actually, this beautiful metric, this beautiful diagram is created by Amin. Yeah, I think it's legit.
Yeah, that was Amim's original diagram he made. Nice picture, Amim. What did you use to draw that, Amim? I don't know where Amim left, and I don't know where he is now, and he can't.
Oh, Amin sent me the tool name. We can find it out.
I think it's actually draw.
Oh yeah.
Then
Excalidraw, is that what you said?
Xdraw. Yeah.
Xdraw? Okay.
And it's used to create this like handwritten graphs.
We had a Christmas drawing competition, and Amim is not really that good at drawing, so I don't really know if he drew this. He sucks at drawing. I'm a way better drawer than him.
Yeah, it's got a like partially hand drawn aesthetic to it. It is a nice picture.
That's not true.
He came back to defend himself. Okay. All right.
Hi, Amin.
Keep going, Zach. What's next? What do you got?
Cool. Yeah. Okay. Let's move on. So after we run the test, you'll see the validation metrics. It implies the connectivity between pods, so we can easily see if the connectivity is successful or not. So there will be 3 parts: expected, observed, and the comparison. It's just like the idea of Kubernetes, right? The intent and the reality of the state. So the intent state should be all the pod can connect to pod 4, and what we observe is all the pod can connect to pod 4, and cannot connect to other pods, which is what we expected. So so there's no difference between expected and observed. Then the test pass. Yep. We have the same logic for all the test coverage for different features like cluster IP, session affinity, node port, traffic local, and headless label, hairpin, host network. So we use this methodology to test all the features and to generate the metrics, so the user can easily identify the problems inside of the cluster, which functionality is not working.
I have a war story here. We just got out of a long customer escalation around headless services recently. They're really tricky because there's no cluster IP. And so you hit a headless service, and Core DNS is load balancing you to the pods. And so being able to diagnose those and test them, especially on like legacy applications that tend to use headless services, is pretty valuable to us, like here at VMware. And I think it'll be, if anybody's running applications like Gluster or Rabbit or, you know, any of these other applications that were written like 2 years before Kubernetes came out, like testing headless services and knowing that they work properly before you deploy those is, you know, we found that to be pretty valuable, you know, to like talk people down off the ledge. You know, it's not our fault. It's like your pod going down. It's not us, you know?
Exactly.
Yeah.
Yeah, and when you want to test against any cluster, it's very easy to run. If you have the kube config file on your local, and if you can run kube-cuttle on your local to fetch information from the cluster, you can always run this project, and you can get back the reports on your local machine with the metrics. Okay, cool. So for the remaining part of this demo, we will go through the code structure, go through the repo, and also show you how to run with sonobuoy. And also I will show you one interesting finding with this project. So we have reproduced one upstream issue which is about the IP table and IPVS modes in kube-proxy is different, behave differently for session affinity service. Okay, cool. So moving on, let's have a quick code walkthrough instead of the repo. I need help from Fang. He has created some of the tests, and also we have paired to force the integration of sonobuoy in this project. So yeah, Fang, can you show the code to the audience?
Sure. I can take over. Thanks, Zach.
Cool.
Can I share my
Yes,
screen?
you may share. So thanks while you're switching. Big thanks to Vlad and Eleanor and John for supporting us in trying to move this over to being a sonobuoy plugin. That's important to us because we want to be able to give this to people to run in a way that's coherent with the way that they normally run conformance tests. You know, like for us, we've got customers and we tell them to run conformance if they think something's wrong. And we use sonobuoy for that. So they've, you know, between sonobuoy and crash, what do we call it? The Vlad stack now? Is that what we call it? They could use those two. They could use them to tell us what's wrong, right?
That's what you're calling it.
And could I just say that the direction, I've got drop in a sec, so I want to get this in. The direction that you're going using sonobuoy for automated cluster validation is exactly what we're hoping the future direction of sonobuoy will be. Sonobuoy is known for conformance testing, and that's excellent, but we think it has a wider use as cluster validation. So
yeah, and I saw John
for what you're developing.
Yeah, and I saw John jumped in on, we were going to build a network conformance suite into sonobuoy, and I think John made initial PR for that, right?
Yeah, that's up now. So it's like, you know, out of the conformance tests, only maybe 5 are networking related, but you know, we don't want to put the onus on every user.
5 are service proxy related.
Oh, 5 are service proxy related. Yeah. So I mean, if there's 100 others that just aren't marked as conformance, it's hard for people to find those, right? Like we need the people who are experts to identify which tests are useful to run, even if they're not conformance. But then we can bake those into sonobuoy. So you can just say, you know, sonobuoy run mode networking checks or something like that. And once we fine tune that list of tests, it'll be easier to run those. And you can run those at the same time as you're running these. Or are these tests particularly disruptive, or can you run other tests in parallel at the same time?
I don't think they're disruptive, but they do create quite a few pods. They're not just some like little rinky-dink, make one pod and make another, and then go to sleep.
Well, if you have a good cluster, I guess it'll be fine. Yeah, we'll see. That'll be a good experiment after.
Can you paste tests? John, can you paste in the thing in the YouTube the link to your PR that adds the network stuff?
Yeah, absolutely.
Performance mode. Cool. All right, fine. Keep going. Sorry, I interrupted you.
Yeah. So maybe let's take a look at the project structure about service validator, and I will take a bottom up approach to explain how the things are organized and structured. At the bottom level, we have some abstraction about different types of Kubernetes objects, including containers, not container, pods, namespace, services, and we also have a model called containers. And each class can be converted to a Kubernetes spec. And finally, there's the functions for those objects to be deployed on the cluster to under test. And we have those entities ready, and we have matrices that aggregates those test objects. For example, our cluster can consist of 4 nodes, and we want to deploy 1 pod for each node. And we can use some of the functions provided by models which keep track of every pod and their protocols. So we have those kind of like the test fixture ready and to be tested. And one thing I want to highlight is when we do the assertions, if we have 4 nodes, then there will be like a 4x4 matrix. We are testing it concurrently using the prop worker. Let me find, where is it? I think it's prop. So like inside these functions, we have 4 different Go routines that and each reachability test is abstracted as a job, a prop job. And in this case, we can experiment the test for the whole matrix, like 16 tests concurrently in an efficient way. The last thing I want to show is
so these run. Wait, so I didn't know we could do that. So how do you concurrently, if you have different services, how do you we have multiple services at the same time targeting the same pods for concurrency, or are you doing new pods and new namespaces?
Sorry, could you repeat your question?
When we do concurrent, are we now doing different namespaces for each test, or are we doing multiple services and we keep the same pod scaffold in the same?
No, we're
doing it within
the same
one namespace. Yeah.
So we don't have a raise hand feature here in StreamYard. We do.
No. No,
Okay,
we just do the concurrency in the same namespace for one test. So we cannot concurrently testing multiple features.
Yeah. Okay.
Yeah. So the features is run one by one.
Yeah.
Yeah.
Okay. Good. Yeah.
Yeah. Yeah.
Yeah. He's just talking about concurrency
like for one test
for how we probe. Yeah. Got it.
Yeah. Yeah. Exactly. So the test case is run sequentially, but within one test case, the matrix is matrix reachability is tested with 4 worker threads.
Yep.
Okay. Yeah. Nice. In the end, I wanna show you how the test case is actually written, and so remember the first, we are using the end-to-end framework here, and the first thing is to do the setup. Every test case goes to the setup, and where we have all the nodes, and we are adding pod to each node. So if we have 4 nodes, and after the text setup function is run, we will expect 4 different pods here. And we assert the pod is ready within each node. And after the setup functions is ready, then we goes to we go through each test. Let's, for example, see a test case where we have surveys for each pod, and we assert they are reachable from one pod to another. So inside here, we are looking through each pod, and we add a service above one pod. And we wait for the service to be ready. That means the service have an endpoint to its corresponding pod. And after that is done, we have set up all the test fixture, and we are ready to assert the reachability behavior. And for this particular case, since we are using end-to-end frameworks, the assertion is here, right? And we are creating a new reachability matrix.
So this is like double Vlad stack, because we have the end-to-end framework.
Yeah,
we forgot to mention, Vlad. So one of the reasons we wanted you to come on the show is that we've got the end-to-end framework as the thing, the batteries that are powering the tests.
I see that.
And then we got sonobuoy on top.
I didn't realize.
What can we do?
I didn't realize you guys were also using the end-to-end test framework. That's great.
Yeah. Yeah, I think it's one of our dependency. The latest is 0.5, I believe. Yeah.
Okay.
Good.
John, you've got to we got to make a John stack. Like everybody on your all's team should have their own little set of.
So is this the J stack?
The J stack is a meme, Zach.
Starts with Myro and
Myro. All right. So by the way, one other thing, Fong, is that, some of y'all will notice these from the E2Es upstream. So we've taken bits from the E2Es upstream. That's how we do the probe function in the other E2Es for like network policies and stuff. So he's like borrowed that and mashed them up with other stuff here. So some of this stuff might look familiar to y'all, and that's probably why.
Yeah. And different from the upstream could be we're using a matrix to represent the reachability, which can be better for diagnosis purpose. Yep. Let's go back to the assertion. Here we are asserting the pod can be reached from each other, using its cluster IP, and we're expecting true here, right? So in the end, this test will only pass if all the matrix is reachable. All 16 dots is showing. All right, I think so. To summarize, the entities are like.
So fine. To visualize this, how can we visualize when you have like the default expectation equals true? Like, do you have an image of this somewhere?
Yeah, I believe so. I think it's inside the validate or fails. There's a print summary where, oh, actually, no. In summary.
So
right.
when we might want to show them what the invocation is from the sonobuoy side, since most of the people here are probably going to be users, even though we would love to have contributors. And we should talk about that, like how people can help. But like, can we show them the sonobuoy invocation and how they actually get that visual table readout that Amin was talking about out of it?
Yeah, actually, it will get covered by the later part of this.
Oh, by the next part. Okay. Yeah. All right. Cool.
Yeah. All right. I think with it, I can summarize like we have entities that represent different resources to be tested. We have all the tests, we exploit the end-to-end frameworks, and we have in the main.test we have everything set up, and finally we are running the assertions during in the assess functions. And the test is running concurrently. I think that's all for the code walkthrough. Maybe I can hand over to Zach. He will talk about how we integrate with the sonobuoy.
Oh, okay.
Yeah, cool. Thank you, Fang. Yeah, so the code logic is we are running different tests against the different features and compare the exact and expect and observe metrics, and to identify if the test is passed or not. Okay, cool. Let me share my screen to continue. Should be this one. Yeah. Can you see my screen?
Not yet.
Let me add it. I think we have you're sharing. I think you're trying to share the wrong screen. You're trying to share the screen.
Yeah, it's the right one.
It's the right one? Okay, cool. Adding it.
Yeah.
Yeah, we got you.
Okay, cool. Yeah, let's get to this part. Sonobuoy. Yeah. Very thankful to Sonobuoy team actually. So have guide, especially Vlad, have guided us through how to set this up, and help us to understand how to use Sonobuoy. So currently, we can run the project into any Kubernetes cluster if you have the kube-config file on your local machine. So we can use Sonobuoy command to inject 2 pods inside of the cluster. The first one is Sonobuoy. The second one is the plugin itself. The plugin is our project, so we will run the binary inside of this pod. Yeah, and it will run by itself, validates the cluster, and then after the test is finished, we can generate the tarball of the result, and then kill the testing pods by itself. Yeah, let's try. It's very easy to run. Let me show you. Yeah, let me open my container. Okay. 1 second. Can you see my screen? Jay, please help.
Let me check. Adding it. Okay.
Okay, cool. Is this legible to you?
Yeah, it looks good. Looks a lot better than what I normally do.
Thank you for that. Okay, cool. Yeah, we just need to yeah. So just sharing the window instead of the screen.
Yeah.
This is what I do. Okay, so here's a cluster. Here's a jumper of the cluster. So we can see. You can see there are many testing. So there are some pods and nodes inside of this cluster. So currently we want to test the stability, the networking stuff inside of the cluster. So this is my local machine. This is my local machine. I just have the kube-config file on my local, and I can use the kubectl kubectl command to get the resource in the cluster. Okay. So how do I test it? In my local machine, I download this project, which is Kubernetes Service Validator. We use make sonobuoy run. It will run. Let's watch the cluster.
Thanks, John, for coming and for all your help along the way, man. It's great to see you.
Absolutely, yeah. I was telling Vlad I've got a couple of small ideas, things we can maybe make better, and maybe he can elaborate on some of them. But happy to work with y'all, and I'm really happy to actually see y'all step through it. I was curious what y'all had made, so thank you.
Okay, thanks, sir. Yeah, get up in here and help us out. Well, ping me tomorrow.
Sure thing.
All right. Okay.
Okay, cool. So after running this command, we have 2 pods running in the cluster. You can see that, which is one of them is called sonobuoy. One of them is called sonobuoy plugin, and we can see the log. We can try to oh my god, check the log of this pod. Okay, it's running. It's running the test. So this pod is running the test
Cool.
to validate the
Can
cluster networking connectivity.
Yeah, so the dots mean it works, and X's mean it doesn't work. And
Yeah.
like when you do things like node port local test, it's interesting because you'll see X's, but it's working because you just don't expect certain things to forward traffic and other ones to work, right? Because if the pod is on another node, you're not going to.
Yeah, exactly. So currently it's testing node port using with UDP protocol, and previously it's testing node port with PTCP protocol, and you can see the connectivities between pods inside of this cluster, exactly this cluster. So it will spin up some of the pod units. You can see.
And we're using AGN host for
It should
our
be
probes. What are we using for the probes? Are we using AGN host or?
Yeah, we're using
Yeah.
as a containers running inside pod.
What proxy are you using in this example, Zach?
Proxy. This is IP table.
Is that a bit okay?
Yeah, this is IP table. Okay, cool. Yeah, in the cluster, you can see there are 4 pods running inside of the cluster, and they are doing the test. And after the test finish, they will be decommissioned. After the test finish, we can also retrieve the report. I will show you later when it finish. Yeah, let's let it run. And in the meantime, let me show you how to run local.
Can you do a get SVC and see the services that are being created?
Yeah, on that left side over there. That's a good idea. So you could show folks
That this is working in the real.
that it's not. We're just gonna make him do something random to prove to us that this isn't a video. Or maybe it's like a deep fake. Oh yeah, okay. See, there's a service. See, it's real. It's really there. Okay.
Cool. Yeah. So the service is also being created. This one is a node port. After each test finish, it will decommission the service it's created. So currently it's testing node port. So there's a node port service.
Oh, there's your node port local one. That's a good one to show people. Yeah. Right.
Oh yeah. We're also testing node port local.
So I think the question or the issue that John wanted to bring up before he left was the use of raw output as opposed to structured output for the test results. So I'm guessing you're doing raw so that you can build a table as and lay out the columnar layout that you have with the table. Is that why?
Yeah. Are you going to put something into E2E that prints a table for us?
Oh, how do you get the table then?
/T quote.
Oh, so you have to jump in the pod.
Print F.
Okay.
Yeah, we're old school over here. But like it would be cool if there's a way to do a pluggable output formatter in E2E framework. I don't know if there is plans to do that.
Not in the E2E framework.
Because it would be great if we could output structured output and then have some kind of a thing that
I mean, without jumping into E2E framework, you can, because E2E framework is basically Go's testing framework. That's all it uses. And with that, you can output JSON if you wanted to capture it in a structured manner. But what I was talking about is actually more specifically for for sonobuoy. Are we getting any of this output via sonobuoy, or you have to go inside the pod or the container to get this output?
I think Sonobuoy is just passing and failing, right, Zach? Or I mean,
Sonobuoy is passing and failing.
Okay.
I don't think it's giving. I don't think we have any structured output from it that we've plugged in.
Okay.
Actually, sorry. Go ahead.
No, I was just curious if you had gotten it to a point where you were also using Sonobuoy to get to the table layout.
Oh, yeah.
I don't think. Yeah. So the output here is so like the formatted output here is only from the validator. We are only passing the done file once it's finished, and pass that the finished signal to the Sonobuoy. We're also wonder if there's some structural way that Sonobuoy can accept result, like a JSON file or some.
Yeah. That's exactly what John was getting to. Is you can use Sonobuoy supports a structured output format. So if you wanted to encode the output in some kind of way, you can do that with Sonobuoy. JUnit being one.
Okay, so like JUnit, what else can you do? Can you send it like a? What else would you send it other than JUnit?
Well, you could. It supports out of the box. It supports the JUnit structured XML, and you can get summary output from that, and it can walk through the results. But you could do your own structured output as well.
How would it parse it if you just made your own up?
Other than so, I know there's another excuse me. There's another format other than JUnit that is supported, but I'm not entirely sure. John would have to give detail on that. But from what I understand, you can use JUnit as a out of the box, but I believe you can do other structured format.
Okay. Yeah. Zach, I see you switch to your browser. Okay.
Yeah. That's thanks for adding it. But we do need to. Actually, currently we are just parsing the output file and to identify if the result passed or not. We did not include the metrics into the result of Sonobuoy result. But people can still check the output, the log of the testing. So you can also see the metrics in the log. Okay, cool. After it's finished, we will retrieve the result and see what's the format we will get in the report. Let's wait for it for a few seconds. For a few minutes, and let's continue to the demo. We can also write on local, so you can use command make summary to have a refined format of the report, and also you can use make summary debug to write on your local machine to have more information in the output. So if you just want to write in a very simple way, just use make test. Okay, cool. I think the test is finished. Let's retrieve it.
All right, cool.
I think the test is finished.
I don't know if Vlad was timing it or not. Which
yes.
I don't know if he was okay.
Okay, cool. So So we can use the command make sonobuoy retrieve to retrieve the result of the testing. The current one is passed. The current one is passed. So we can see the detail of the log in your local machine, and you can see, yeah.
Oh, so you
all the
can see that.
Yeah, it's in the result folder. It's in the result
Okay.
folder.
How is it that sonobuoy retrieve? What are you doing? Like you're untarring the sonobuoy tarball and then you're catting the result. Is that what you're doing? You're catting the logs, or what is that? How are you getting? Because sonobuoy retrieve normally gets a tarball, right?
Yeah,
Yes.
that's a tarball. But in the command make sonobuoy retrieve, we also do we also do unzip on the tarball.
Oh, that's nice of you. So you're unpeeling the whole thing for us. Okay.
Mhm.
Yeah,
I think that's
so
fairly new.
so we run the sonobuoy retrieve on this folder, right? And all the information will show up here. So this is a result. This is all the
Oh, okay.
Got it.
Yeah.
Oh, so it's already coming back structured. Okay.
Okay, cool.
As JSON, right? Is that what it is?
I think it just yeah.
What kind of
JSON file.
JSON is that?
I know it says .json.
That's the weirdest non-JSON .json file I've ever seen in my whole life.
Hey, it works.
Yeah, I was about to say it's not JSON, but I saw this .json. Maybe it's a JSON file, right? Yeah, not JSON folder format.
Definitely not JSON.
Yeah. Okay, cool. We have used this tool to test against the cluster, which is very easy to run. We just use make sonobuoy run and make sonobuoy retrieve to get back to get back the result. Yeah, I think we have done the demo of this project, but I still want to include one thing, which is very interesting finding using this project. Before I work on it, I never know about this issue. And it's hard to reproduce actually, but using this project, it's very hard. It's very easy to reproduce. This is about session affinity. So when you have a session affinity cluster IP service, if you have the same client to reach to the cluster IP service with session affinity, the result, the behavior is different in kube-proxy IP table mode and IPVS mode. So in IP table mode, the session affinity is attached to the specific port.
You're going to need to zoom in on that a little bit for us in a second.
Oh, cool. Yeah. Cool. Thanks for saying that. When the same client reach to the IP table mode session cluster IP service, the session affinity will be attached to the same port.
Hi, Scott. I didn't know you were here. Scott is here, and he's talking about how much he loves IPVS.
Hey, Scott, what's up?
All right. Keep going. Keep going. I just wanted to say hi,
cool.
Scott. Yeah.
So the request from same pod will go to the different target pod using different port number. This is a result from our matrix. This is a result from our matrix. So in the matrix, we see when we're using port 80, we have established the session affinity like 3-pod reach to PAF0 and 3-pod goes to PAF1 pod, and we observe the same. So we use this to establish the session affinity, and then we try to use the same client reach to the same service using port 81, and then we expect the same session affinity. We expect the same target pods for all the pods, but it's different. So this time we have different targets. So each pod goes to a different pod, target pod using port 81. Yeah, this is IP table. This is its behavior. But if we are using IPVS, when we establish the session affinity using one of the ports, and then same client to reach out to the same cluster IP service using another port, they will still go to the same target pod. This is the metrics we get from the tool. When we use port 80, so we create created the affinity, and then when we use port 81, they are reaching out to the same target pods. Yep.
So
Cool.
wait, what? The affinity semantics should be the same in the upstream IPVS and IP tables. If this was KPNG, I'd be like, oh, we screwed everything up. That makes perfect sense. But this is, oh, I see. You're running, okay, so you port 81, port 80, cluster IP service with session affinity, cluster IP. It's the same service. So why are these behaving differently? Is there a bug in IPVS?
There's an issue. I think it's a.
Oh yeah, there is 103.0.0.0. Okay.
Yeah.
I was so busy worrying about what time it was in Israel that I didn't look at the issue on the top.
Yeah. There's an issue.
Scott Rosenberg is from Israel.
Yes, exactly. But I don't think it's got solved. Maybe we just need to update the document, or we need to.
That's really cool. That's really cool, Zach. I didn't know we could reproduce that test failure yet. That's really cool. And you're right. It is a good way to visualize the difference.
Yep.
You're getting creative over there.
Yeah, I wonder like what the other proxies behave like. Are they failing? Like, do they behave the same way as IP tables? Like Antrea proxy, for example.
It's very easy to try, but I did not include it here. We can try offline. It's very easy to do it actually. Just run this project in the different setting of the clusters, in the different networking settings of the clusters. Yeah, let's try. Let's try later. After this.
Yeah. So right now in CI, we're running Cilium. I don't know whether it's CI or not. It's just in the manual benchmark thing that you built the other day.
That is a CI.
That's all running in automation. So we're running what? Cilium, Antrea proxy, IPVS, IP tables, and KPNG IP tables. So we're running 5 different service proxies.
Yeah.
Okay, cool.
Yeah. And we can add more if there are, because technologies are evolving. Maybe there will be more nice solutions.
Yeah.
Yeah, and also we have this command to aggregate the result from different CNIs, so we can see if the CNI support the networking feature.
Yeah.
Like Cilium does not pass the node port traffic local, and Kapang does not pass session affinity yet, which need to be fixed.
What about Antrea? Did we find any bugs in Antrea?
Antrea, actually, we need to work with Antrea team closer for that to identify if the issue is legit or not.
We think we may have found something with Antrea proxy. Okay, cool.
Yeah.
All right, let's file some issues and see if we can.
Yeah.
So I suspect every service proxy is going to have varying differences with tests, but if that'll be cool. We can file some issues and then we can bother Junjen some more.
Yeah, exactly. Cool. I think it's already more than 1 hour. In this session, and maybe we can wrap it up. Do you have anything to say, Jay and Amin, from?
My mother-in-law got me this hat. Do you all like it? This is my hat for the show.
Oh, it's beautiful.
It's very professional. as Zach would say.
Okay.
Good show, Zach. That's really I really appreciate you coming on and doing the show, and thanks Amim for mentoring and helping these folks build this out, and Fong Han, thanks for not sleeping for a month while you were doing another job and helping Zach along the way.
Yeah.
Yeah, nice work. Nice work.
Nice work.
So next we need to, let's see what we can do to get this more deeply integrated into Antrea CI somehow.
Yeah.
I don't know, Jiunjen, if you're still on the show, what do you think? You think if we filed an issue, we could start running this as part of Antrea CI jobs and outputting the results? I think we would really like to do that. If we're planning on trying to get this integrated with the SIG network jobs as well. Amim demoed this about a year ago, and Tim Hawkins was on board with that. But we always like to put things in Antrea first if we can, just because it's a really good proving ground before we go full on upstream. We'll give him 5 seconds to answer. He's probably gone now. Everybody's going home now.
There's still 7 people watching.
Oh, there's still 7 people watching. Okay, cool.
Yeah.
Well, we can
subscribe, like the video, and all this YouTube stuff.
That's in my ending.
Like and if you all are enjoying the show, please do like and subscribe. It's really cool. We've got a lot of subscribers to this Antrea group ever since we started. So
yeah, and also
that helped us to justify continuing to put this party on for you every Wednesday.
Mm-hmm.
Yeah.
Oh, Jinjin replied.
Definitely. Okay, that's a handshake. He's handshake plus wanting the idea. Cool.
Awesome.
All right. Well, we know where to find you. We'll see you in the office tomorrow.
Okay, cool. Yeah, let's put an ending here. Thanks all for joining and spending time with us. The Beyond Data will get better, and along the way, we hope we can get your help. Just submit PRs, issues, or open a discussion in the GitHub repo. For this project, we spend time and we open source it. I hope it's useful to the community. And last, if you like this session, please click the like button, subscribe to the channel, and even turn on the ring bell of this channel so you will never miss any Antrea live session in the future. Okay, have fun.
Like and subscribe. I'm just going to come out and say it. If you like us, then subscribe and come back.
Yeah.
Awesome.
Okay, cheers, guys.
Cool. Everybody say thank you, Zach.
Thank you.
Nope.
No. Jason said it last time. All right. See y'all.
Okay, see you. Bye.